Let's start data at urban scale. This is one of my projects I did in Media Lab 2016, I guess. This project is actually talking about the third place data in terms of analyzing some particular area in your urban context. There should be two types of data, like continuous data and discrete data. So in this project, I'm trying to narrative how we extract urban data and then we interpolate discrete data as continuous data, because every data has actually their own relationship between them. So in this context, I'm trying to mimic sort of a complex system to play with data based on the network system. So I think I don't need to explain the project, but we can just focus on the data and methodology, okay? So in this, the picture down there, this is like a plane of a district. So, a space in a city, there are different types of data, as I said, such as like a sunlight or slopeness or wateriness, like wind or viewability or things like that. So what if we actually parse this kind of information in real world to the digital world? So in this context, we can create some of a pixelized area to catch the individual space. Each space talk their neighbor. So actually we have a better system to process the data in different layers. Just imagine that we have this kind of data structure, and then we have a multiple agent that they have their own sort of rule or tendency to looking for some place. So for example, I don't like sunlight, okay? I really like walking through under the sun, for example. Based on different circumstances or tendency, we can define the space as a numerical data or numbers. And this is another urban data project, but these days it's become very conventional works. But what I did is in Boston area, there's two types of data. We have like sort of top-down data. Top-down means like the government or agent, they actually create the data set on the basis of their purpose, but I don't know. But what I'm saying is all top-down data has their own purpose, and then bottom-up data is actually individual create the data, and then we're trying to understand what is the relationship between top-down and bottom-up data in this project. So I used the, as I said, the Boston local government provides us with a lot of data, like building energy or some economic or social information. Also, I parsed some real estate information from Zillow and Craigslist. Also, I parsed individual like the Google Street Map based on this pixelized area up there. So at the end of the day, we get like more than 100 dimensions in each area in that pixel, which is representing a space. By looking at some correlation or let's say supervised or unsupervised learning, we can sometimes prove our assumption toward each space, or sometimes we can actually find some interesting things that we need to address. Or this is sort of the derived result not only has something to do with their own data layer, but also it has something to do with some data that we forgot. So I think this is very interesting explanation and the process, the iterative process to dive into understanding physical circumstance or situation with data. I think this is very interesting in terms of setting up design process with data. I guess this is not about the design, it's more about like how to use your design intuition. It's more about like domain knowledge. So what I mean by that is the computation design is not just about understanding and deploying some computer science knowledge. It's more about like a converge, setting your own design process and thinking process in a computational way. This is my thesis project, Harvard GSD. There are actually two different processes. One process is just like a machine learning things to train the existing information to predict something in the future. Second phase is more about like a reconstruct a geometry on the basis of the prediction that machine provide. On the second phase, I think machine error could be machine creativeness, because just like a big factory, we can precisely mass product something. We can see there is no creativeness, right? However, someone did something that we never thought about it. So we can consider, oh, this is like a very creative approach and things like that. So what I'm trying to do is how I ask machine produce something that we never experience out of prediction by machine learning. The color is very essential information for design with shapes. There are conventional way to process two different color, like blending mode. There's like screen or multiply. I couldn't remember all of them, but it provides us like some equation to process pixels. I took advantage of this kind of equation to process three-dimensional voxelized area, because individual voxel has their own pixels. So we can actually consider voxel as a multiple layer of pixels, like a two-dimensional array. So this is also talk about how we process the spatial information, and then how to reconstruct the 3D geometry out of 2D image. Let's jump out of the topic.